Now we're looking at a little bit more in exercise 5.6, parallel and perpendicular lines, and referring to them in terms of their gradients. Lines that are parallel, like these two black lines on the screen, as we all know, parallel lines don't cross. What it means is that they have the exact same gradient, because the rise over the run from any 2 points on this first line would be exactly the same as the rise over run from any 2 points on the second line. So they have the same gradient. If the first one has a gradient of 3, the second one has a gradient of 3. The opposite of that is lines that are perpendicular. Perpendicular meaning that they make a right angle with each other. So obviously they do cross, but what we have here with gradients is we have something a little bit different, and what it's called is the negative inverse. So for example, we look at the first blue line, it's got a positive gradient. The brown line has a negative gradient. If, for example, the positive gradient is 3, or as we say sometimes, 3 over 1, then the gradient of the brown line, if I change my colour pen to brown, make it a little easier, the gradient of the brown line becomes the negative inverse of 3 over 1. Now the inverse means flip it upside down. So I change it to 1 over 3 and change it and make it either a negative if it wasn't, or a positive if it already was. Because the first one was originally positive 3 on 1, this becomes negative 1 on 3. So it becomes the negative inverse of something. To show you just another negative inverse of something, if we have down here the number negative 2 on 5, well, the negative inverse of that becomes 5 on 2, and the negative of a negative changes it to a positive. For example, find the gradient of line parallel to each of these ones. So question 1, find the gradient of a line parallel to the first one. Well, if it's parallel to y equals 2x minus 5, it must have the same gradient. Therefore, its gradient is going to be 2. Nice and simple. Second one, same thing. We want to have the same gradient. This second equation, 2x plus 3y equals 6, is not in standard form, so I don't know the gradient yet. I have to rearrange the equation, so let's do that first. 3y is equal to 6, subtract 2x when I take the 2x across the other side, and then divide both of them by 3. 6 on 3 minus 2x on 3. Simplify it out. Now 6 on 3 becomes 2 minus 2x on 3. So the gradient of this particular line is negative 2 on 3. The gradient of a line parallel to that would also be m is equal to 2 on 3, negative 2 on 3, the exact same. Now we'll look at perpendicular lines. So if we're looking at a line that is perpendicular to a particular line, that means that the gradient is the negative inverse. So first of all, let's find the first equation. Let's look at its gradient. We're in standard form, we've got it. We can see therefore that our m is going to be 4, or 4 on 1. We like to talk rise over run. Therefore, the gradient of the perpendicular line is flipping that one upside down and changing its sign. Negative inverse of 4 on 1 becomes negative 1 on 4. Same process occurs with number 2, in that first of all I need to make sure that my equation is in standard form. So let's do some rearranging. First thing, negative 5y is going to be equal to 10, subtract 3x. Taking the 3x to the other side. Now divide both of them by negative 5. 10 divided by minus 5, minus 3x divided by minus 5. Simplifies out to negative 2. And then plus 3x on 5. My two negatives here cancel each other out to make a plus, and the 3 on 5 stays as it was. So, I have an m value in this instance of 3 over 5 for that equation. Therefore, the m, or the gradient, for a line that is perpendicular to this one is the negative inverse. Well, the inverse, instead of being 3 on 5, becomes 5 on 3, and I make it a negative. So you can see that the negative inverse is flipping a fraction or a whole number upside down and changing its sign. That's exercise 5.6. Good luck with those questions.